Okay, is it on? Can you hear me? Great. Excuse me. Okay, so yes, as Chris said, my name is Jenn Caselle, and I am a marine scientist at the University of California at Santa Barbara. And today I'm going to talk about I'm going to give you a quick rampage through the California situation of our MPA network, from design through to monitoring. And I do want to acknowledge my co-authors, especially the first one, Dr. Mark Carr. He's a professor at UC Santa Cruz, and he and I have been working together for a very long time on this. So this is a brief outline of what I'm going to talk about today. I'll start by very quickly giving you some background to the California MPAs. And then I'm going to dig a little bit deeper into how science was integrated in our process, and dig a little bit deeper into some of the design guidelines. And then I'll finish where we are now in the California context, which is adaptive management of our network. And I'm going to be pleased to show you some very recent studies that we've published in the last year looking at the MPA network performance. So California, here's California. Key to implementing the California MPA network was legislation. And it's a little bit different the way we legislated this than I've heard from some of the other speakers. So the enabling legislation was called the Marine Life Protection Act. You'll hear me call it the MLPA. And it was passed into law by the voters of California. California, we're famous for legislating by ballot initiative. So the citizens of California had enough interest in this that they put this onto the ballot, and then the voters of California voted this legislation into place. So it was mandated, but it was, I don't know whether you call that top down or bottom up, but it was legislation. So that guided the development of the network of marine protected areas. And what it did is it basically specified that the existing MPAs in California, which were small, ad hoc, not particularly scientifically designed, that they get reorganized and designed into a scientific, coherent network of marine protected areas. So that's the Marine Life Protection Act. So the marine protected areas, they were established between 2007 and 2012, but actually the Marine Life Protection Act was passed in 1999. And then the process for implementation started in 2005. And this is a story for another time, but there were 3 tries at implementing the initiative, implementing the legislation. The first one failed, the second one failed, and the third one succeeded, and that's what I'm going to talk about today. And if you're interested in why those first efforts at this failed, happy to talk to you about it. Failure is important. Just to give you a little bit of scale here in the European context, California is a really big state. We have about 1,350 kilometers of coastline. And so this is in part the reason why that the process proceeded regionally and why it took so long. So 4 regions, the central, the north coast, and the south coast, each was developed sequentially, not at the same time. And our network now we have 124 MPAs that cover just about 2,200 square kilometers. 16% of our state waters, and everything I'm going to talk about today is not out to our EEZ because we're talking about the state, so out to state waters. 63, just about half of our network, are complete no-take reserves. So we're currently about 8.4% of state waters. And the others allow for some take, and later in my talk I'll touch upon the kinds of take that we allowed. They would almost be considered fully and highly protected compared to some of the allowable uses I've heard through this conference in the partial takes. Okay, so the Marine Life Protection Act was guided by very specific goals, 6 in particular, 4 of which I'll focus on today. These are just These are my summaries of more detailed goals in the legislation. So we were guided, this will become important later, having clear objectives and clear goals written down in the law guided the design, it guided the implementation, it's guiding the monitoring. So The 4 that I'll really focus on today have to do more with natural diversity, ecosystem functions, communities, populations, habitats, and so forth. But you can see that there were other more social goals as well. And the 6th is important. It was mandated that we had to ensure that the MPAs are both designed as a coherent network and managed as a network as well. On the topic of networks, I probably don't need to explain this to this group. There's been a lot of great talks about the importance of networks for various reasons, insurance and against catastrophe and so forth. So just in terms of population connectivity, the idea here is that by having a network of highly connected, in our case, smaller MPAs, that populations may be able to contribute to replenishment, both to the MPAs and to outside areas, right? And the other idea then is that networks in this cartoon you can see may actually increase the potential footprint of a replenishment area with smaller, per smaller unit of actual reserve implemented. So there's many other reasons for networks, but this was a sort of fundamental principle for us, was thinking about our network as a connectivity network. Mark asked me to really talk, to come here actually, and by the way, I forgot to say thanks. Thanks to all of the organizers, to Mark for bringing me here. How rude of me, right? Bringing me all the way here from California. It's been a fabulous conference. And I was asked to speak about how science was really, how science was infused into the process in California. And so in summary, my idea is I think there were 4 key conditions that supported what I consider to actually be really strong science integration. The first was this legal mandate, right? But more importantly than the legal mandate, we had consistent political support for science-based design for this network. The planning process, which I'll talk about in a minute, was structured to integrate what we called the best readily available science into the decision making. And by keeping it, as best readily available science, we could proceed and move forward without getting too hung up on, we need more science, we need more, we need more. We had what we had and we made it work. The scientists were able to come up with simple science-based design guidelines, and these were all linked explicitly to the goals. And then there was just continued input from scientists throughout the planning process. People have done some estimates. I can't, untold thousands and thousands of hours, both formally and informally, by scientists in California. We have a lot of scientists in California too, so marine scientists. So this is a little bit busy, but this shows the governance structure for the planning and design, which is the bottom half of the figure, and the MPA management that's occurring now on the top half. So if we just focus on, I'm really simplifying this, but on the design process. It took a long time, and 3 groups were put together. One I won't talk about much, the Blue Ribbon Task Force. That group was higher level, folks who know about policy, folks who know about law, and they could provide policy guidance for the MPA proposals that came through. But these 2 are important. For each region of the state, regional stakeholder groups were convened. Right? And these, I've listed some of the sectors and some of the community members that made up those stakeholder groups, and they were big. And they were appointed to these groups, and they also acted as representatives of their sector. So they went out and talked to their people and came back to the working group meetings. And then there was for each region, a science advisory team too. And the science advisory team was tasked with providing I'll tell you in a minute, I have a slide for what the science advisory team did. So the way this worked was that the regional stakeholder groups, they were responsible for creating the maps, the proposals. We used a C-sketch, which I'll talk about in a second, and they had access to all of this sorts of information, all of these layers that went into the tool, and they created maps with their constituencies, with each other. And all the science advisory team did was evaluate their proposals. The science advisory team did this. It's probably more important what they didn't do. So the science advisory teams were generally responsible for providing just scientific literacy across the whole initiative. That's to the other groups involved, to the public. And they developed these design guidelines for what we thought were an effective network of MPAs. These are things like size and shape, location, spacing, and that's what I'm going to dig into detail a little bit in my talk. And the idea was then also to convey the scientific basis of those simple guidelines to the other parts of the process, to the regional stakeholder groups and to the task force, and to the public, and to agencies even. And their main goal was to evaluate the proposals that were developed by the stakeholders for meeting those guidelines. And at least, if not more than 50 scientists served on SATs across California. There were about 20 in each region, and some served in more than one region. And they were very multidisciplinary across all aspects of science. We did use a decision support tool. At the time, it was called Marine Map. It became C-Sketch, so some of you may not know C-Sketch's origin story, but it was Marine Map. And earlier in the week, Will McClintock was here, and he developed this program, and a lot of you are now using C-Sketch. So people have talked about it. You may be familiar with it, but it allowed for collaborative design. It allowed for mapping. Stakeholders could draw concepts of individual MPAs. They could draw network concepts, and then they could get some basic feedback. Certainly Marine Map at the time was not as sophisticated as C-Sketch is now, but they could receive basic feedback on their designs against the guidelines that were developed they were supposed to follow. But importantly, when they were ready, these concept proposals went to the science advisory teams where they were evaluated in more sophisticated ways than Marine Map could do at the time. So that's a really quick rampage over the process. I want to also add too, though, that the California marine protected area development, like every aspect, is so well documented in the literature. There's been entire books written about it. So I've tried to put some references as I go along, but I can certainly provide specific references if you have specific questions about aspects of it. Super well documented. So these are the key points on the process. It was stakeholder driven, it was highly participatory, thus it was also incredibly time consuming, and it was expensive. The network design that we ended up with is, we were helped because we had clear goals in the legislation that were identified that we could meet. I didn't talk much about it, but we used both ecological and physical attributes in the Marine Map to design the network, as well as bioeconomics and social sciences as well. And really this is the key. I mean, I'm a scientist. I would love if this were all about the science, but it's not all about the science, and I think everyone in this room knows that. It was really about a successful process where people felt engaged, but importantly in our case, we felt engaged. The process allowed for science to be used in a meaningful way, well, at least in my opinion. So our final network is a balance in both science and socioeconomic considerations. There were a lot of trade-offs. I don't think anybody was perfectly happy, but everybody could live with it in the end. And I'll probably say this 16 times through my talk. The law was imperative. Okay, so that's the first part of my talk. I want to get into the second part a little bit. The science guidelines. I'll go through this relatively quickly. It's maybe a little bit in the weeds, but basically we developed these really common sense, simple rules of thumb for the stakeholders to follow. And what I'll talk about today is just key sort of aspects of designing a network: habitat representation and replication, size and spacing guidelines, and a little bit about level of protection. I don't have time today to talk about the spatial bioeconomic models, but all of the proposals were also evaluated using these spatial bioeconomic models. And here's one reference where one of those models is described. Okay, so pretend you're a stakeholder. This is kind of how I'm gonna run you through like what we would do. So I'm not gonna be very technical and very scientific. I'm going to tell you sort of how we approached the communications in the stakeholder groups. So habitat protection, representation, replication, key components to a network. You all know that. For us, these addressed the specific goals 1 and 4 of the MLPA, and we started with just these really simple super common sense goals. If you want to have a network, you need to protect a variety of marine habitats across a range of depths. And indeed, you should include each habitat in multiple MPAs distributed across any environmental or biogeographic gradients that you have, right? Makes sense, okay? So what does that mean, though, when you want to explain to stakeholders some of the science? So this was kind of the level at which we would explain these things, backing it up with scientific papers and so forth. But the idea that we know, and we knew a lot about this, ecosystems vary by bottom type and by depth. So different species, different species in different communities, they live across different depths. Species assemblages can vary with different habitats. And this cartoon shows a lot of California examples of what you might see in our system, as well as good evidence for ontogenetic shifts as well across habitats and across depths. Secondly, we knew quite a lot about the biogeography in California, super interesting. It's a large state, as I said, so we know that ecosystems varied geographically between and within biogeographic regions. Here's a cartoon showing what kelp forests might look like, one habitat, as you go from the north to the central to the south. But even within, this is where I live, really fascinating place, the Northern Channel Islands. I think some of you saw them in the movie, The Ocean, really. I'm so lucky. Great place to work. But even within Southern California, we've done work to show that there's a high degree of structure in the communities. Okay? So that's sort of the example of how, what the sound science would be, backed up, of course, with all of the literature. And then to translate these into more specific guidelines, this is an example of what the guidelines that the stakeholders had to follow. So each key habitat had to be in the MPAs. The habitats had to range across depths. They had to be from the intertidal to the deepest portion. And even getting more quantitative, proposals needed to include 3 to 5 replicate MPAs for each key habitat within each biogeographic region. So it's not the details that are important here, it's more how we did this, the level at which we did this. So the MPA proposals then could be assessed against these guidelines. So another example, population protection, MLPA goals 2 and 6, designing as a network, size and spacing are important. The rationale is here. They should be large enough that adults should stay within, at least for a portion of their life. The MPAs should be large enough to include multiple habitats. And in terms of spacing, they should be close enough together that larvae can move from one to another and replenish the populations, both within the MPAs and in between areas. And again, we had a lot of information about adult movements in California. These cartoons are all California fishes. We know that our reef fish don't move very far at all. Some move a little further, some move a little bit further. But this was important because what this did is we weren't setting the goal of protecting every single fish species in California. So presenting this kind of science allowed us to explain to the stakeholders what might be likely to be protected and what might not. And I think that's actually really important. And it also knowing the actual ranges of movement, set some information for us on size of MPAs and also on spacing. Similarly, we had some information on larval dispersal distances. This was probably the one area where the science was kind of the most new or not well developed back when we were designing this. It's moved the furthest for sure. So we had some estimates from, in this case, genetic information about basic larval dispersal distances. We knew that seaweeds tended to not be dispersed that far, invertebrates very wide-ranging, and fishes even more so. So this gives some idea of what scales, what sizes we could make MPAs where they may be self-replenishing, as well as distances at which MPAs might be spaced in order to support replenishment one another. I do want to say, though, that we have come a really long way, and I don't have time to talk about it much today, but we have a really good ROMS models now. We're doing a lot of connectivity work. We weren't able to use this for the design, but we are definitely using connectivity studies. I hear you nodding, just like what you were talking about, to evaluate the network. So that's been really, and also we can forecast with our ROMS model as well, so lucky in that way. And this is what ended up being the size and the spacing guidelines So this is, it's California specific, but that's how we got there. So again, this could be, the MPAs could be assessed against this. We also, this is the last guideline I'm going to talk about before I get into adaptive management and the idea of protection levels. So we started with this rationale, pretty simple. We started with, if MPAs allow human uses, their conservation is going to be diminished. Like it or not, that's what humans do. We do that. And we wanted to consider those potential impacts to all the varying levels of ecological complexity that we pulled out of the MLPA legislation. And in our case, we used a framework where we predicted the conservation level by comparing to a no-take, no-fishing marine reserve. That was kind of our baseline for this. And don't worry, I'm not going to go through this, but we created a decision tree that was really an early precursor, I think, to the MPA guide that so many of you have talked about and been part of designing, which is an amazing resource. And it started at habitat. If an activity altered the physical habitat, you were immediately shunted down to the low and moderate side, and then worked through other levels of complexity, populations, communities, and you could end up with a conservation value of high, moderate to high, all the way down to low. And if you want to know more information about this, the Emily Sarman's paper here details that. And this is what our network looks like. So we ended up with what we call state marine reserves. Those are no-take, no damage. Those are the highest level of protection. We have 49 of them, about 9% of state waters. And then what we call state marine conservation areas, SMCAs. Those allow for some activities, but I just want to highlight this in the blue. 10 of our state marine conservation areas are no-takes for fishing. But they had to allow some activities like maintenance of infrastructure that was in the MPA. So it was kind of a legal thing, right? They couldn't be called an SMR. They had to be called an SMCA, but there was no fishing. So these actually fall into pretty fully and highly protected. And then restricted take SMCAs. There's other designations, but they're a very, very small part of our network as well. Many people don't even know about these other things, that they even exist, So the implications for multiple conservation levels in our network, again, I didn't have time to talk about the bioeconomic models, but they basically did two things. They evaluated the conservation values and they evaluated the fisheries values. So what the protection guidelines really implied was that only the MPAs with the highest level of ecosystem conservation, only they got to count towards the conservation goals in those models. But there were other goals, remember? Research, education, tourism, and so forth. So MPAs with lower ecosystem conservation levels could count towards those other goals. And when I bring up this counting, now's a good time to say that all of this that we did is now impacting California's 30 by 30 process. The US did not sign on to the 30 by 30 initiative. In fact, we're rapidly moving backwards in that. But California did, through an executive action of our governor. We're all in. And so we started with we started with our network of MPAs, so we're already ahead of the game, but we are in very interesting conversations about what should count towards our 30% of our coastal waters. And we are using now adaptations of the MPA guide to make some of those decisions, and another great document, which is the OECM guide as well. And I'm happy to talk more about that. Okay, I'm looking for a clock on my computer, but I see it. Okay. So the last part of my talk is where we are now, right? Which is we have our network, we have a management plan, and the network is even starting to get to be of a good, ripe old age. And we're in this phase of doing adaptive management. And adaptive management is actually written into the legislation as well. We have quite a few guiding documents to guide us in this adaptive management. All of these are available online, and there's even more. There's a lot more. We have a master plan, which is our version of our management plan, and that's a living document. It's very much a living document. We work on that thing. We update it and so forth. This is sort of interesting. I'll conclude, one of my key points will be that partnerships have been really key to this whole thing. And there's a whole guidebook on the California collaborative approach. It's a guide to collaboration, partnerships, and how you can make these things work. And then, of course, in my area of interest, lots of the monitoring action plan and science evaluation, science guidelines that we've been developing that sort of guide the monitoring. And the program as a whole for MPA management in the state of California has 4 what they call pillars: research and monitoring, outreach and education, enforcement and compliance, and policy and permitting. And there's a lot of work that happens across a lot of agencies, a lot of community members, a lot of scientists in these pillars, if you will. But there's also a good amount of collaboration and they're not as siloed as these little icons would indicate. So this is the fundamental division of how we manage the network. But I'm, being a marine scientist, going to focus on research and monitoring for the rest of my talk and some of the ecological outcomes for what we found recently. So why evaluate MPA performance? Well, besides the fact that it's actually mandated in the legislation, we have to monitor by law. Besides that, it's really important. It's critical to adaptive management, which you cannot do without learning and feeding that learning back into the process. That's what adaptive management is. We want to know if the MLPA policy is achieving its goals. It also just generally, globally, advances our understanding of MPA design, but also specific aspects of our own design. Did those guidelines work? Were they too coarse? Were they too prescriptive? Did they work? Did they do anything? So we're constantly doing monitoring and feeding back to trying to understand if our design worked. And in California, I will say, the network can get changed. Right now, the managing agency, the Department of Fish and Wildlife, is evaluating petitions from the public to change the network. They got over 50 of them. Some wanted more MPAs, some wanted MPAs to go away, some want to shift the boundaries, some wanted to change the uses. So it's truly adaptive management. I have my opinions about that as a long-term data taker and monitor. I'm not wild about changing the network, but we'll adapt. It's adaptive management. Also, in California, there's been a pretty huge investment in marine protected area monitoring, and increasingly, this is in water, on boat kind of field monitoring, and increasingly, that monitoring is becoming the basis for providing data to inform other management issues in California, like fisheries and so forth, because it has been so well funded, and it's required by law. So the monitoring not only specifically addresses the goals of the Act, but is being designed to inform other processes. Briefly, I think I've said most of this. The monitoring is guided by several action plans. It's directly linked to the MPA goals. The way we think about this, my friend, Professor Mark Carr, and myself, and what went into these documents, we first articulate the goals and the objectives, and then generate questions that we think are answerable with qualitative and with quantitative metrics, and that involves identifying indicators of performance. I will just mention briefly as well that I haven't heard much in this symposium yet, but we have a very large number of tribes, of First Nations in California as well. And so a huge amount of effort, they were involved in all of the stakeholder groups, but we're making a huge effort now and a big push to really engage tribes in monitoring, but more importantly, try to understand how we can use traditional ecological knowledge and other ways of knowing into some of these evaluations. And that's been a real learning process for a lot of us scientists and for our tribal member partners as well. So speaking of adaptive management and evaluation, we're constantly doing small evaluations of the network, but the managers have created a schedule for a very overarching, huge evaluation of the network, but all of those aspects. The policy, the compliance, the permitting, the research and monitoring, all 4 of those pillars. And this was completed recently in 2022. And this document, which is also available online, covers all of those areas and how we reviewed them. And this was a seriously all hands on deck kind of situation for pretty much everybody in the state. We worked for years to prepare for this, this evaluation. And yeah, again, I can talk more about that over coffee if you have questions or so forth, but I want to make sure that I leave time to show some of the ecological results now for the marine scientists in the room. We, as part of that decadal evaluation, we put together a working group at a synthesis center, which happens to be located where I live in Santa Barbara. It's NCS, the National Center for Ecological Analysis and Synthesis. And the working group was composed of scientists who were local, people like myself who do the monitoring in California, but also many other folks who are international, including several European scientists whose names I'm sure you would understand. And so to think about helping us with new ways of thinking. So I'm going to talk about 3 papers we've published recently. First, overall network performance, a little bit about what our MPAs did in the face of a serious climate disturbance, and then human engagement across the MPA network. And these were some of the data sets that we used. We have long-term data sets from multiple habitats. This isn't even all of them, but these are the different habitats that we used in these various synthesis project. Oh, and I should say that until this synthesis group was put together, there was still quite a lot of output, but it was all from scientists only from their own habitat. So this was the first example where we got everybody around the table and we consolidated these data streams in ways we could use them to inform at a higher level. So first, MPA performance. The guiding question here is one that it must be the first question that a lot of us ask in MPAs. Are the fish bigger and are there more of them in the MPA? So what was the effect of regulatory protection on fish biomass? And this directly addressed the MLPA goal number 2, which has to do with protecting populations. So here's what we did. We used these data streams from these 4 habitats all the way from the surf zone down to the deep reef. Our metric of interest was the response ratio. We've seen this before, log of the biomass in the MPA over the reference area. And here's our network. We did this analysis at multiple spatial scales for different reasons. And I'm going to actually explain the reasons why we did this and our links to the managers, which drove the spatial scales we chose. So we did an all network analysis. We analyzed region by region, and then we looked to within to see if we could see patterns across the habitats. So basically what we found, I'll just step you through this because the next couple plots look like this. First, we did this for the no takes and for the partial takes. Here's our effect size. This is the network level performance. And what we do as well in a lot of our analyses is we separate out the species that are targeted by fishing, because those are the species we think are more likely to respond to MPAs. Yes, indirect effects will eventually affect the non-targeted species, but we always separate them. As we use non-targeted as sort of a counterfactual, if you will. Okay, so what we found is that there was a positive network level response when we pool over all of the habitats and all of the regions. Now, interesting to me, the effect was actually larger in the no-take reserves than the partial takes. And that may not, it was surprising to me, it may not be surprising to a lot of you, but here's why. I said I would tell you about our partial takes. Here's examples of the kinds of things we allow in our partial take. First thing is every MPA has a different rule. So one MPA, the take is recreational lobster only. Another MPA, the take is commercial salmon only. Another MPA, the take is you can do a hook and a line from the shore. That's it. So those are, and each MPA has like one of those things, and they're all different. So, so it's not, our partial takes, we're not trawling and things like that. So this actually was surprising to me. Okay, I'm going to move it along. Quit telling stories. At the regional level, we found that, and we knew this already, that we had serious biogeographic patterns with the strongest effects in the south, where all the people live, and the weakest effects in the north. And our models showed that the regional performance increased with age, pre-implementation fishing pressure, and habitat diversity. And because I have very little time, I won't go into detail, but I will say that when we did this across the different monitoring programs, we did find variation in the MPA responses, even in the same MPAs for the different habitats. And so this kind of thing, not that interesting scientifically necessarily, but it definitely guided us in future design changes to our monitoring program. All right, next up, climate resilience. This is a huge question the state is asking of our MPAs right now, and really all over the place, I know. Do MPAs provide any kind of ecological resilience to climate-driven perturbations? We had a giant marine heat wave from the period about 2014 to 2016 in the Northeast Pacific. It was huge, made a lot of really interesting effects on our ecosystems. And so what we did, the timing was great if you're a scientist, because it was right in the middle of all our monitoring. We had data before and during and after. So we looked at the community structure in all of these different ecosystems. This one is showing the rocky intertidal, and you're looking at an NMDS plot here showing community structure. There's a lot going on. The colors show the heat wave period before, during, after. The dashed line and the solid line show MPA, but see how they're all on top of each other? In the rocky intertidal, there really wasn't even an effect of the marine heat wave on the communities. But in the 4 other ecosystems, there were. What you're doing is you're following the colors. Here's where the community sat before in the blue, shifted and shifted again afterwards. But interestingly, MPAs and their paired reference sites shifted in the same way. We saw no resilience to the marine heat wave in community structure across most of these ecosystems. We also saw no return back to the original conditions after the heat wave. I will leave you on a little bit positive note. These data sets ended in 2019. Some really recent work we're doing has sort of kind of indicating a little bit that these systems are, in the MPAs, they are actually recovering faster than outside. And we have a paper coming out next week that shows that with kelps. And finally, Chris, one of my favorite works that we did, this was really new. California puts a lot of emphasis into biological and ecological monitoring. We are a little bit deficient in our social and socioeconomic monitoring, and we know that. But we wanted to know how human engagement was distributed across the network. We literally had no idea who was using these MPAs for what, or for how, or why. And this was MLPA goal number 3, which is improving recreational educational opportunities. So my collaborator, Chris Free, and that NC's working group, we used some really interesting data sets. MPA Watch is a citizen science program in California where they go to all the MPAs and they watch the people and they write down who's there, what they're doing, even dogs, birds, all of that. eBird and iNaturalist are those, maybe familiar with this, these are those big citizen science online programs where people put geotagged photos. And so these are huge data sets, and we were able to get all the data from them, billions of records. REEF is a citizen science scuba diving program, and then we got some data from the agencies on how many scientific permits they gave to work in an MPA or another one, and the citations that they gave in MPAs. And we put all of that together. You're looking at, here, I'll walk you through. These are all the individual MPAs. Doesn't matter what they are. Remember, we have 146 of them. The first column is the important one here, and that is the population size. It's millions of people within, I know, it's California, right? It's millions of people within 50 miles of the MPA, not hundreds. And then these are the other levels of human engagement. With purple is a lot of human engagement across those different data sets. And so what we see, right, is what you would think. Places with low population density, a lot of these MPAs had lower engagement. A lot of these MPAs in Southern California with high population density had higher engagement. You just, squint your eyes, look at the purple. But we also had these sets of MPAs, which we called charismatic, where very low population density nearby and very high engagement. So what is going on there? We created models to try to explain. Done, almost done. I just love this so much, though. We also argued whether we should call them horrible MPAs, or we went with underutilized. So charismatic MPAs, turns out, these are the overutilized ones. People don't live nearby and they're used a lot. They tend to have beaches. They're older, for one, but they also tend to be near beaches, and this is important, they're near parks But not just any parks. They sit within another designation. So they sit within a national marine sanctuary or a state park or something that people know about, right? And these parks have infrastructure. They have bathrooms, they have parking lots, and so forth. The underutilized MPAs, they're remote, they're inaccessible, they don't have beaches, they don't have parking lots, which means they probably don't have bathrooms, and those are the underutilized ones. So that's 3 examples of some recent work we've done on performance across various dimensions, and I'll just wrap up here then with just a few take-homes. The Marine Life Protection Act, it was important because it was legislated, but it took a lot of funding, a lot of resources, and a long-term commitment. So there's still funding. It wasn't just for the process itself of implementation. It's taken a long-term funding commitment. Took serious mobilization of the scientific community, still happening to this day. Coordination among a lot of different agencies. What I've seen in the last couple days, Europe is really complex. You've got a lot of overlapping jurisdictions. California does too, actually, and we have a lot of competing agencies too, maybe not quite as much as Europe. And outreach and collaboration with communities. And this is my big take home, is partnerships were and continue to be key. Not everybody agreed. In fact, almost nobody got everything they wanted, but everybody stayed at the table and continued to talk, and they're still doing it to this day. So thank you. I'm sorry if I went over time, but I did tell you that I would.
Thank you very much, Jen. It was a fabulous presentation. And incidentally, I was trying to think, the first time I heard a presentation about the California MPA network was, I think, in 2009. And only the first site only the first region had been done. And I still remember, I think it was probably the second best presentation I've ever heard. And there were a limited number of CDs available at the end, and that told me how long ago it was. And I was incredibly happy I got one of those CDs.
Oh, lucky you.
Thank you for your presentation.
CDs, you're dating yourself, Chris.
It's probably a collector's item,
Yeah.
I saw there's a hand straight away at the back and the middle.
Thank you. Sebastian from the Norwegian Institute for Motion Research. In 2004, you received an award for recognizing your work with diversity. Now in the US, you have anti-DEI diversity, equity, inclusion movements from high up in the government level. How does this affect your work on diversity in marine protected areas and beyond?
Yeah, I was kind of hoping we wouldn't go there. It's been so refreshing not talking about the situation in the US here in this meeting. Nobody's insulated from what's going on in the US right now, but we are California. We have the 5th largest, 4th economy in the world. We have a strong governor. We're insulated a little bit more than some of the other places. It's unclear yet how those sorts of changes coming down from, especially with regards to diversity, equity, inclusion, are going to affect specifically the MPA process. I will say a couple things. One, there is no doubt that funding is in huge trouble right now from the federal government, and universities are under huge threat, so that's going to just sort of put a lot more burden of funding on the state and on private philanthropy for a while, I think. So that's going to affect what we do. But yeah, no, nothing, we're forging on ahead. We're California. I don't know what else to say. Yeah.
There was another question from this gentleman.
Hello, thanks for a great presentation. John with the Blue Marine Foundation. I'm really interested in this charismatic MPAs. We have our first national marine park in the UK at Plymouth. I'm interested in whether that concept leads to better science and better research and better citizen science, and we actually see better returns on the conservation objectives of sites. Did you monitor that in those charismatic sites? I think that.
Yeah, no, informally we know that. So we have monitoring programs in each of the regions, and they're not all of the same amount. So for example, Northern California, inaccessible, super crazy rough conditions to go out on the water, very limited. And so in terms of at least the long-term data sets, those data sets are just not as rich. They're gappy, And that does affect our ability to assess performance when we have data sets that aren't as complete as, for example, in Southern California. So that's an indirect sort of thing, but we haven't looked at it specifically. The state has tried to create a monitoring framework where everything is being done the same way and across the whole state. I don't know if that answers your question or not.
On the right.
Yeah, thank you so much, Jen, for fantastic, for telling this story in a new way and updating us. I'm involved with the Institute for Marine Research, and so this case from California, as Chris mentioned, has been an inspiration for much more than a decade now. And now we're in Europe, we're in Norway, we have a 30 target 5 years away. And we're still looking to California in many respects. We've heard about the Azores case today, but we also know that the common fisheries policy is sort of moving in the background. And will we be able to actually commit or to actually realize some of those destinations? But that's a different story. But my main question that I want to give you is, let's say that academia were not as actively involved as you have been, and still are. Let's say that this process would be up to the agencies, and maybe NOAA federally. How would that play out without this really active scientific community? And is your talk a call to action for scientists to get involved, get deeply involved for the long term?
Yeah, I mean, I think it is, because of course I always think more science is better if we can do it. And I think that as scientists, we have a lot to say. And many, many years ago when I started in this whole thing, we were scared. I was scared to get involved. I thought it was going to be advocacy or something like that, right? To step into the fray. And, those days are over. We don't have time to be passive and sit on the sidelines. So I do think California probably is unique in the sheer number of scientists that we have along the coast and the involvement. It's hard. That's a great question. It's hard to say what the process would have looked like if the academics weren't involved. But I will add that a lot of that monitoring, the in-water monitoring that I talked about, those are citizen science groups. It's been a really important thing for the state to involve all levels. So I'd have to really speculate to say what it would look like. But I showed you sort of the level of the science that went into the design guidelines. It was pretty high level. It wasn't rocket science, right? So I think we probably would have gotten the same sort of network. I mean, it was common sense. We just said, let's just use the data we have at the time, and let's just use common sense. So maybe we weren't needed at all, actually. Couldn't think of it. I don't know.
There's still quite a few
Yeah.
which
We could.
I could take two more, one from each side. Please try to keep them short. I think originally there was this lady just there. Thank you very much.
Thank you, hello, I'm John at the University of Bodø. If I got it right, you have some perplexities about deductive management that I get right, and what are these about?
Sorry, somewhat about management. The acoustics are actually very bad, and I have bad hearing.
If I got it right, you said you have some perplexities about adaptive management. Did I get it right, and what are these perplexities?
The complexities with management, is that what you're asking?
Perplexities.
Perplexities about adaptive management.
Oh, about adaptive management. Well, I'm not sure even where to start or how to do it briefly. Would it be copping out if we could talk at the coffee break about that? Yeah, okay, thanks. Sorry, no, I ate up too much time. So find me.
One more session.
It's only a short comment. You didn't talk about the people who objected to all of this. And I happen to have a neighbor, it's Carl Waters, and he's a good friend of Ray Hilborn. And he tells me all that Ray Hilborn has tried on behalf of the university, or the university, to try to sabotage this thing.
Yes, hugely.
For those of you who may sympathize with Ray Hilborn, he has been a major opponent on behalf of the fishing industry against this network.
Yes, he has. Yeah, and yet, you know what? We talk to Ray a lot. We invite him down for seminars. We're still talking. So, but you're right. He's a He's an outspoken critic. He's an outspoken critic.
Thank you very much.